Okay, for this last video that we're going to record, what we're going to look at are some physics applications that we're going to be able to solve using our knowledge of calculus. And before anybody gets too terribly worried about the physics, we're just going to keep doing the same thing all year long. We're going to look at position, we're going to look at velocity, we're going to look at acceleration. Every now and again, we're going to dabble in the concepts of speed, displacement, total distance traveled, but we're generally talking about a particle moving, right? A particle moving along the line, so you're moving forward. The particle might stop. The particle might move backwards. The particle might be running forward, so you're speeding up, right? But generally, everything's going to come down to a particle moving on a straight line, or a cat walking forward. Or we look at problems where I'm taking my daughter for a walk through the neighborhood. We sometimes will look at projectiles, like when I throw the pen up in the air. I know that the height of the pen changes over time. That's going to be the velocity. How the velocity changes from being positive to negative. How the velocity changes is the acceleration. But generally, that's as far as we're going to go with the physics. So don't worry too much about momentum and all the other kinetic energy and potential energy. We're just going to focus on the physics of movement. And for those of you that are going to take the Calculus BC course with me, we're eventually going to get past, motion just on a straight line. And we're going to look at motion in a two-dimensional plane. But for now, let's just worry about movement in one direction. Okay. So, position. Position is usually going to be measured in meters. Sometimes it'll be measured in feet, but sometimes we're going to refer to it as x of t. That is often going to be the notation that we use. Some books refer to it as s of t. If we're doing a height problem, we might refer to it as h of t. But position is normally going to be one of those three things. What's your position at a particular time? If I want to look at how your position changes over time, right? Velocity is just a measure of how is your position changing. Are you moving forward, in which case your position is increasing, so your velocity is positive? Or are you moving backwards, in which case your velocity is negative? Velocity, what we need to keep in mind is that it is a measure of change in position over change in time, which means that normally the units are going to be something like meters per second, might be miles per hour, it might be feet per minute, whatever it is going to be a measure of distance divided by a measure of time. The velocity, because it is a change in position over change in time, it's actually the derivative. It's a dx dt. It is how your position is changing over time. Acceleration. Acceleration is measuring how your velocity changes. So if we're looking at a change in velocity over a change in time, well, velocity is normally measured in something like meters per second. Time is measured in seconds. So when we're looking at acceleration, the units will be meters per second, or equivalently, you could write meters per second squared. The units are essential. You must have the right units in order to get the point. In terms of the calculus, what I want you to remember is that since acceleration is how velocity changes over time, it is the dv dt. It's how your velocity changes over time. You could say it's v prime of t, right? It's the derivative of the velocity. Well, if it's the derivative of the velocity, and velocity is the derivative of position, then that actually means that it's two derivatives on your position. If I start with my position function, I take one derivative, I get velocity. If I take another derivative, I get down to acceleration. And it's really this connection of function derivative, function's second derivative, which is why we do so much calculus with physics. So let's look at a typical question and see what we can do. A rocket is launched from a platform 10 feet above the ground. The height of the rocket, h of t, which is measured in feet, the units are going to be feet, is a function of time t, where the t is being measured in seconds since the rocket was launched. If the height of the rocket is given by h of t equals negative 16t squared plus 64t plus 10, determine the following. A, the velocity of the rocket at 3 seconds. B, the acceleration of the rocket at 2 seconds. And C, the maximum height reached by the rocket. Let's move on and try this. All right, we're given that h of t is negative 16t squared plus 64t plus 10. And I want the velocity at 3 seconds. I want v3. Well, how do we find the velocity at 3 seconds? We need to know how is the height changing when time is equal to 3. Previously, we would have done limit as t approaches 3. We'd find h of t, which is negative 16t squared plus 64t plus 10. Minus, we would find the height of the rocket at 3 seconds, so we would plug 3 in. 3 squared is 9, that's times negative 16 is negative 144, plus 192 is 48, plus 10 is 58, over t minus 3, and we would go through, limit t approaches 3, negative 16t squared, plus 64t, plus 10 minus 58 is really negative 48 over t minus 3. Limit t approaches 3. Let's see, I've got negative 16, positive 64, negative 48. I'm pretty sure they all have a common factor of negative 16, which leaves me t squared minus 4t plus 3. T minus 3 in the denominator. We've got now limit as t approaches 3, negative 16. T squared minus 4t plus 3 factors as t minus 3 times t minus 1. I was hoping that t minus 3 would be a common factor of the numerator and the denominator. I can take the limit now, I can evaluate it. Negative 16 times 3 minus 1 is negative 32. So the velocity at 3 seconds is negative 32. My units should be feet per second. There it is. That's option A. Let's label that as option A. Option B. I like option B a little bit better. Since we know that the velocity function is the derivative of the height function, most people have figured out the shortcut by now. Since the velocity is the derivative of the height, we're going to take the derivative of the height function. How do we do that? We use the shortcut method. The shortcut is we bring the power down in front and we multiply. 2 times negative 16 is negative 32t. We reduce your power by 1, so it becomes t to the first, plus 64t. Well, that's really t to the first. 1 times 64, 64. T to the 0 power is just 1. 10 is a constant, it's not changing. Its derivative is 0. So we get negative 32t plus 64 is the velocity function. If I want to know the velocity at 3 seconds, I'm going to plug that in. Negative 32 times 3 plus 64 is negative 96 plus 64. We get negative 32. The same negative 32 that we got before, and we were able to skip over the whole limit process because we now know the relationship of the derivative there. So negative 32 feet per second, either way you choose. I choose option B, which is we just take the derivative and plug in 3. Great. Let's move on to the next question. Part B, if the height of the rocket is given by h equals negative 16t squared plus 64t plus 10, same problem as before, determine the acceleration of the rocket at 2 seconds. I need a of t. Well, what is a of t? Well, that's supposed to be the derivative of the velocity. But the derivative of the velocity is the second derivative of the height. So let's go through and do this. H of t is negative 16t squared plus 64t plus 10. If I take one derivative, we've already done that, we get negative 32t plus 64. If I take a second derivative, I get negative 32. No t. That means the acceleration is the same everywhere. Well, what's this acceleration? The acceleration at the 2 seconds is negative 32. What are the units? Feet per second per second. That might seem awfully familiar. Negative 32 feet per second. What is that? That is the acceleration due to gravity. It wasn't an accident that it comes out to be negative 32. All right, let's move on. If the height of the rocket, same problem, h of t, negative 16t squared plus 64t plus 10. I want the maximum height. Well, let's imagine I'm on my little platform up here. My platform is 10 feet above the ground. I fire a rocket. The rocket goes up into the air. It comes back down. Where that happens, that's the maximum height. Well, why did it reach a maximum height? It reached a maximum height because the velocity is equal to 0. So in order to solve this problem, I take my velocity function, which we already determined to be negative 32t plus 64. Because I'm at the maximum height, the velocity is equal to 0. I can solve that. Negative 32t equals negative 64. So t equals 2 seconds. What that means is that when t is equal to 2 seconds, the rocket is at its maximum height. The question asked me for the actual maximum height, so I need h of 2. H of 2, negative 16 times 2 squared plus 64 times 2 plus 10. 2 squared is 4 times negative 16 is negative 64 plus 128 plus 10. If I do that correctly, we get 74. The units are feet. So the maximum height of the rocket occurs 2 seconds after the rocket leaves the ground. And is 74 feet. Done. That is a typical physics question that you are likely to encounter in an AP Calculus class. What I want to do in this next video is look at a much more challenging, much richer problem, and hopefully be able to accomplish that in the next 20 minutes.